So let us continue. As we finish the discussion, we have two problems, right? And 1.17, if we have FDMA and if we have DDMA with A-way time multiplex, and so that we are asked to have the number of simultaneous codes. And next one, we are asked to have the result for MN1. And if we double the rate, arrival and the service rate, and then what are or how are system length and system time changed? Now, because this one finished, so let us check the reference solution. Alright, so you have the solutions, but what are the correct solutions? So this one. Let me check this for you. First of all, this one, you can check it. And maybe I remember one of you mentioned, oh, okay, even we have the given number of codes, we reserve one, so minus one, so that we have 660 minus one. That one is still okay, because you mentioned we need to reserve some codes for the management. So, first one, A. Because of FDMA, so we have the frequency over the frequency band 25. Alright, and because of full duplex, so full duplex over, so full duplex for each one. And then we have the simultaneous code. So the current channel over these. Because of two duplex channel, simplex channel, so that for duplex voice channel, so this one and over two, so we have this one. And the second one actually is simple, because A-way time multiplexing, so times 8. Well, so this is a reference solution for this problem, it's okay. Alright. And actually, you can get back to check the video so you will have the answer. If you want to keep this one easy, so you can take a picture. So if you want to do so, you can take a picture for the solution to problem 1.17. Well, it's okay. So no problem, then we move on to the next one. And this one, we don't have the solution directly, but actually we should check the formula. Alright, so you can check the formula for system length and check formula for time. Well, so actually later you can look at the formula. Actually for the formula we have a rate and over rate and service rate. If we double them, we can cancel if we double rate and the service rate. So this one, okay, no problem. So same. But the time, because we have it's half. But time actually we don't have the rate in the numerator, so we will have the original time. So this one you can check the formula. And actually I remember last time the presenter showed the result can be shown easily, right? Alright, so that's it. This is the second problem. Alright, also, and let us continue the discussion today. So before we continue here, I'm going to have further questionnaires and let me know the status of you about the current EMI course. So, first question, up now, how do you feel about our EMI course? I don't have a specific meaning for this, but then you understand what it means. So then you have 1 minute for each question. Alright, that's okay, no problem. Yeah, maybe some of you have to feel somewhat worried. Near 20%. Fine, no problem. Alright, let me check. Not finished. If we're finished, then we can continue. So let me move on to the next one. If we're not finished, you just let me know. And how about the pass of the lecturing? Yeah, some of you feel okay, too slow. Most of you feel okay. That's good. Well, Sam, let me make sure not finished. Okay, then we move on to the next one. Actually, for Taiwanese, you should understand we have some resources in Chinese. And for the other students, okay, some of you failed to notice this. We have a video on YouTube in Chinese, so you can refer to those if you need them. And for videos of current lecture, currently I have the videos using streaming, so you can check the playlist of streaming. But sometimes I will add video to the playlist a few days or a few weeks later. If you want to check that immediately, you can try to check stream videos on my YouTube channel. So maybe some of you failed to notice this. So that's why I want to let you know, yes, we have the actual resources. Well, not finished? Alright, so it's okay. Some of the questions somewhat like serving as reminders. And how about the resources? And are these resources helpful to you? So finished? Oh, okay, so even some of you fail to know this, but all of you agree with these. These resources are helpful. Okay, good. And if any possible help you still need, maybe you can let me know. And I should let you know, all the questions here will still collect the points for you. Each one 2 points. Alright, so for this one. 20% well understood. Oh, 30%. And most of you feel so far so good. Alright. But why none of the above? Actually, the current choices, some serving as good and some serving as bad. Or so far so good, simply, oh, okay, it's fair. And I'm curious about the item here. Some of you think, oh, okay, none of the above. So, any possible idea about this? Why none of the above? If you choose that one, can you share your idea with me? Let me know. Okay, fine. Alright, second, finish or not finish? Okay, seems to be okay. Then we move on to the next one. Finally, this one. Even we do not heavily rely on these, but we have a free classroom teaching. For example, last time we asked you to have the video viewing first before you come to the classroom, right? And it doesn't mean I will frequently rely on this, but at least we have one possible item like this. Can this accepted by you? So can you see? No? So let me try this. So you can accept, that's good. And again, commercial, not finished. Okay, so almost finished. And let me try this again. Yeah, about this. Can you have it? Your suggestions? No? Actually, the first one, maybe many days ago, or maybe many weeks ago, he or she answered. Apparently, no. Okay, fine. Alright, so, okay. Alright, so you know, maybe I just follow the third way to have the EMI courses, and hopefully you still can find it's helpful, or maybe it's okay for you. So, done for all of you. Alright, so finish for this. Therefore, finally, this one. It's a different one. Basically, I use those serve as the activities, but this one for attendance, attendance checking. So scan, and you can put your ID and the name on all value. Okay, go and finish this. have 12, but here we have 14. So not finished. Okay, so let me go to the next one. Alright, so last week we finished the discussion using jigsaw. Jigsaw to talk about the propagation mechanism. So anyone still remember 3 propagation mechanisms there? If yes, raise your hands. Of course, allow you to be the presenter to answer the current question. Even I don't pose a question here. 3 mechanisms of propagation. 3. Anyone want to try to answer my current question? Sure, allow you to check your slides. So, any 3 mechanisms? And at least, okay, Alice, right? So, wait a moment. Allow you to answer, wait a moment. Ready? Go.
So the 3 mechanisms are reflection, refraction, and scattering.
Scattering, reflection, and diffraction. Yes, correct. Reflection first, diffraction, and scattering. If I follow the order of slides, right? Okay, so you can indicate you are the presenter, alright, line group, and so the tutor will collect that for you. So it's correct, and after finishing one, propagation mechanism, and right now, let us check effect. Alright, so right now we have all of the mechanisms to have the effects. The red one, so the normal one, right? And this one, reflected signal. So because of reflection, therefore we have the effect from reflection. And the reflected signal. And also scattered signal. Therefore, still based on the 3 mechanisms to have the scattered signals, reflected signals, and the reflected signal. And don't forget, do we expect scattered signals, reflected signals, and reflected signals to interfere the original desired signal? Here is the direct signal. No, right? However, the other signal here comes from the same source. However, will be received at the same site. At the same site, of course, we will have the undesired signals from reflected one, scattered one, and so that even coming from the same source. These serving as the interference. Alright, so here we will have an interference if we have the propagation effects. Well, how to have the further capture? So we want to check maybe from a simple one, then to have a bit more complicated one, so that we have the first case, free space propagation, and so that we just consider, oh, okay, we can propagate and receive signal at a distance d, and then what's the power? The power follows the formula, and we have some constant parameter. And P sub T means the power of a transmitter, and P sub R means the power of a receiver. And for D actually is distance. So we will have something like it's a principle. The power will decay as actually maybe with the distance, and it's inverse proportional to the difference, and it's d squared. So we have all of these. As for the others, I think we think there are some possible constant. Even we can have a name. I skip the details and then know. Oh, okay. Initially, we will have the attenuation effect caused by distance. And here, this is a free space propagation. And of course, we can have the others because later we will have some further details for the other models. Well, here we talk about antenna gain, and antenna gain follow the possible formula. You just check it, and I allow you to have 2 minutes to check it. Even we don't have the discussion tonight, but these are given formula. Just follow the given formula and then what is the gain. Just calculate the result. Then you have 2 minutes to check this page. Just a formula. So, current discussion, the current content here just allow you to have the calculation in G. So almost the answer means about finding. Oh, okay, we can have a formula. So why we have the formula? It doesn't mean we should check these like this. We have the formula. And finally, that's the formula here. If we can have the proper way to change it, oh, okay, we care about frequency. So what's the relationship of gain and the frequency here? Oh, look at this. Gain actually proportional to the frequency and proportional to frequency squared. That's why higher the frequency and higher the gain. So this is the relation if we have a formula. And because of this, we can have the higher gain. So not only if we want to have the transmission, it doesn't mean we want to stay within the lower frequency band. In fact, we expect to have the higher frequency band to have the transmission because of higher gain. Right? So that's why we need to move maybe signal within the passband, lower frequency band to the higher frequency band, and so that we can have a higher antenna gain to achieve the high efficiency. Alright, so the fact here, I emphasize the fact here, so the formula actually we don't have any specific reason to explain. Maybe if you have some chance to study antenna, and then you will know the formula. But we just apply and so that we can have the induce some like conclusion. Higher the frequency and higher will be the gain for some given antenna size. Alright, so this one just serving as the reference. So we have the propagation through distance and the effect through distance. And later we want to have a different formula, and this formula says, of course, we can have gain at the transmitter and gain at the receiver. And of course, initially we have the transmit power, and so that we have the receive power. And after analysis, we will want to enhance it so we have a gain. the gain try to amplify, to enhance it, but only gain. In fact, we have a loss. So actually we have L, and L here we have the accumulation of 3 possible losses. First of all, path loss. Path loss says, as distance, as actually if we have a distance, if you move and then longer distance causes the path loss. And then we have slow fading and fast fading. These cause to loss as well. So we have 3 different terms. And 3 different terms are why L is the multiplication of the 3 factors. Because we want to accumulate. Well, maybe you have a question. Accumulate by y is the multiplication. Actually, if we talk about the real calculation, yes, gain multiply. So loss actually dividing and dividing and dividing. So we have 3 different terms. And if we have the different way to calculate gain and loss, for example, we can use log. If we want to measure loss or gain in terms of log, then we will have a sum of the possible terms. But currently, they are absolute values, so we don't have any specific manipulation. Therefore, we have the multiplication directly rather than sum of all the terms. And in the exercise, sometimes we use dB decibel. dB, then we can have the log included in the manipulation so that we can change the current operation into the form of sum. Right now, though, we have the original value or the absolute value. So we have the multiplication for all losses and multiplication for all gains. Alright, so this one. And later we want to separate the 3 effects or 3 types of losses into the individual one and want to check or we want to investigate how to have the individual effect. Why we have the individual effect? Well, for the loss we have the multiplication correctly. So that way allow us to have the individual investigation. That's why we start from path loss first. You see what that means? Path loss. Signal strength decays exponentially with the distance d between the transmitter and the receiver. And this one we call the path loss because we have a path. As if we move further to leave the current, maybe it's the receiver. Move and to a different distance d, and then we will have a loss caused by distance d. And this kind of loss, of course, it is called path loss. And if we want to have a path loss under the effect of distance, then it's really simple. Let us have the transmitting power and the over received power. Then we will have a loss. And if we want to have gain, actually it should be received power over the transmitting one. But even we have that one, it doesn't mean 0 or none of the losses. So now, therefore, we investigate losses first. And this one actually, someone based on the field trials and saw that they can have some experimental result. Once they have an experimental result, then they found some relationship. First of all, loss. The path loss actually related to distance only. Previously it says yes, so we know the possible term caused by distance d. And only distance no. This one still depends on frequency, carrier frequency. So if we have the large carrier frequency, then we will have a high value of path loss as well. Why higher than we have the path loss? If we have a high frequency, based on the formula, speed equals equal to frequency multiplied wavelength. So high frequency, then we have a really short wavelength. Really short wavelength, then it will incur possible blocking by any buildings. So of course, if we have a large frequency, then we work with the pass loss for sure. But follow the current formula. Alright, so we have these. And it says, well, if we have all these, depends on distance and also depends on carrier frequency. And then we have the pass loss. And so then it says, oh, previously we just care about distance, but how about frequency? Yes, frequency depends as well. Therefore, we have a highlight here. And we also mentioned this one. Well, we know d square, but don't forget, previously d square for which model? Free space, right? And right now, if we have the communication, for example, in metropolitan area, and also consider a different scenario. Oh, okay, maybe we have a really wide area without any buildings, and if you consider that case, so since that one apply to free space, but right now if we consider metropolitan area, then it doesn't mean d square, because d square to, for example, d raised to power to 2.5, 3, and actually can be 4. If we have a d square, it says, okay, the effect not so serious. But d raised to power to 4, and this one is really serious. So this is the environment, for example, in metropolitan area, because we have many interference, and so that include those, and so that how about the loss coming from the pass loss? Yes, even higher if we don't think d square can reflect the facts. We will change it to d, for example, 3 and d 4. It's possible. So depending on the environment, then we will have the exponent of distance. So this one as well. And for the current formula, if we have a free space, why this one different from the previous one? In fact, this is the actually the field trial. Field trial, of course, we have the possible terms after trial. So this one, it should be the exact one, but the previous one is the simplified one. So the previous one, we do not have the formula like this. And here, we use it to serve as a pass loss in free space. Well, again, we still have the pass loss. And pass loss d square, no, right now we have d raised to power to alpha. And alpha actually is the propagation constant. And the value for alpha, if we do not consider free space, normally we should have 3 or 4 for urban area. Right? And then no metropolitan area, we will have the severe effects coming from pass loss. So of course we should have the exponent raising from 2, for example, to the current one, 3 or 4 for the typical urban area. Alright, that's it. So, let me stop here simply and allow you to have a short discussion and thinking about currently what we reach and how we have the possible conclusions. Alright, so maybe let me check the seats again. And maybe for good Alright, so no problem, no need to change. And for good one, yeah, you can get closer to have the possible discussion. And for Jen, your name Jen? Okay. Is it okay? Okay. And feel free to have the discussion for the current items. And you can get those. So I now have 3 minutes to discuss, and later if you have no question, then I can move on to the next one. Okay, so the current activity in the past has been called turn and talk. And turn and talk actually allow you to have the chance to have a discussion with your teammates. And then you can refresh something and so that you won't fall asleep, right? So it's called a turn and talk, but Last semester, I tried to have a questionnaire. Do you think turn and talk efficient? They don't have any idea. And so then this time I didn't know the meaning, what that means, turn and talk. Alright, so turn and talk, maybe, okay, don't waste time. Continue. If I continue, perhaps you fall asleep. Alright, so even we can pause, allow you to have a chance to think. It's the pedagogy. Alright, so even pause, and then you have something to think. But let me check. Up to now, any questions? So if no, here, alpha 3 to 4, right, in urban area. And so then I have a question. How about alpha in a suburban area? Similar to 3 to 4 or lower? I can't call suburban area. Here it's urban area, so suburban area, it doesn't mean the free space. So that value should be comparable value like the urban area or a bit lower. You try to guess. Comparable, lower, or maybe higher. Which one you think? Lower. Yeah, lower. Okay, agreed. So yes, it's true. If we don't have any, even no buildings, just trees, that's okay. So the value should be a bit lower, perhaps 2.5 or something else. But for free space, and then it's 2. Alright, so this one. And the current formula, you see, it's the simplest formula. If we don't care about the others, we just care about distance. And then pass loads depends on distance. But previously we have the formula depends on carrier frequency. So it doesn't mean purely depends on distance. But distance and the frequency are almost the same. They have the proportional weight. So in terms of first of all, in terms of the current formula, actually, all frequency and distance almost the same way, right? But dB actually it doesn't mean the pure quantity. We try to transform, for example. Okay, so the pure one, but we try to change it to, for example. And this one is called dB. Alright, so dB actually will have a logarithm. Base is 10. And we have this and multiply 20. So we have the dB. And if we have a log and multiply the previous one, so we should be, this one multiply the frequency and the distance. Alright, so we have these. And actually, I don't know if we have the way to have the calculation, perhaps we can collect sum rather than the multiplication. But we want to have the pure quantity. As on the current formula, it should be the multiplication from frequency and the distance simultaneously. So both carrier frequency and distance affect the loads, the passive loads. So I emphasize dB. And later we show all the results in terms of dB, decibel. And the decibel, then, first of all, we show the current figure like this. First of all, look at this. Frequency here. So from the first one to this one, what it means? Low frequency and high frequency. And high frequency here. So lows is high or low. Frequency we have a formula related to frequency. Higher frequency equals high path loads. So the curve actually shows the first one. as frequency becomes higher, then we have high capacitance. And how about this and D? Increase D actually the increasing trend. So the current figure actually we illustrate the relationship capacitance related to carrying frequency and the distance. And right now in free space. Keep in mind, okay, the label is lower than 130, right? So urban area. At least higher than 130. So we will have an even worse situation considered later. And we may have an urban area. Of course, we can have a suburban area. And later we can try to check, oh, okay, if we have the same one, but what's the capacitance for different scenarios? So later we will check it, but let us get back to this one first. Alright, so currently we already have the trend. So the current trend actually covered by that equation to simultaneously illustrate frequency, carrier frequency, and the distance can affect the capacitance. Alright, that's it. So let me make sure any questions. If no, time to rest first for 10 minutes.